Hi, this is a second lecture on the topic of looping as it applies to JavaScript, and I'm going to continue on with the program example that we looked at last time, the program being how we could apply looping to generate the Fibonacci sequence. And if you recall last time, in my user interface, I provided a upper limit. And if I said, for instance, I wanted to generate a sequence with 5 numbers, then when I click the button, it would show me a sequence with 1, 2, 3, 4, 5. And you recall the Fibonacci sequence always starts with Fibonacci 1 value of 0, Fibonacci 2 value of 1, and then thereafter, every Fibonacci value that follows is going to be the sum of the previous 2 values. So in this case, Fibonacci 3 is the sum of Fibonacci 1 and 2, Fibonacci 4 is the sum of Fibonacci 2 and 3, and Fibonacci 5 is going to be the sum of Fibonacci 3 and 4. Okay, so all that should make sense from last time. Last time we used a for loop to generate the sequence. We input the number of values in the sequence that we want through a text box, and in fact we're going to do the same thing here. Okay, so if I were to type in a value of 12, say generate the sequence, you would see that it would eventually generate the first 12 numbers in the Fibonacci sequence. Now what's different this time is that I'm enforcing a rule on what value I can input here, and my rule is that the number that I enter must be greater than 2 and it must be less than 20. Okay, so I came up with this rule somewhat arbitrarily, but nevertheless that's my rule, that this program is designed to generate the Fibonacci sequence for any range of values between greater than 2 and less than 20. So what happens if I violate the rule? What if I put in a value of 1, which is clearly not within that range? If I indicate I want to generate the sequence, it will eventually come back with a alert that says the upper limit must be greater than 2 and less than 20. And if I violate it on the other end with a value of 21, again I get that same alert. Okay, so if I put in a value of 19, that's okay. If I put in a value of 3, that's okay. So somehow, some way, this program is examining the input that I provide here and making a decision as to whether to generate the sequence or not. And if you've been, following what we've done up to this point, then you're probably thinking, this sounds like he's going to be using a nested control flow structure. That's exactly what I'm going to do. And I will be using a nested control flow structure that looks like this sketch right here. I'll make a decision. If the decision evaluates true, I'll go ahead and loop through and generate the sequence, and then I'll be done. If the decision is false, then I'll fire off an alert message and make no attempt to generate the Fibonacci sequence. So what we have is a looping structure that is nested within a two-way decision structure. In other words, we would have a for loop that would be nested within the true path of an if-else statement, and we would have an alert here that would be nested within the false path of the if-else statement. Now, I want to consider the decision that's being made. In order to generate that sequence, 2 things have to be true concurrently. The value that I input has to be greater than 2, and it also has to be less than 20. So I need to evaluate 2 things concurrently, 2 expressions concurrently, and if both expressions themselves individually evaluate true, then I want to take the true path and generate the sequence. But if either of the expressions evaluate false, or if both of the expressions evaluate false, then I don't want to generate the sequence. So how do I evaluate two expressions concurrently? Well, what you need to know is that we have a couple of logical operators, one called and the other one called or, and they are used for exactly this purpose. So when we need to evaluate two expressions concurrently, then we have to decide, do they follow the logic that is described here on the left or the logic that's described on the right. And that logic is being described using something called a truth table. Okay, so the first time I learned about truth tables was in a computer architecture class. This Boolean logic that can be expressed by way of truth tables then is something that applies to programming, and it also applies to other areas like circuit design. So how do you know which one to use? Well, first thing I would tell you is that there are a number of truth tables that can be used, especially in computer architecture, but in programming there are two operators that you need to get familiar with, or and I think the easiest way to do this is just memorize these truth tables. Okay, stare at them long and hard, and after you've looked at them long enough so that when you wake up tomorrow morning and the first thing you see before you open your eyes, are these truth tables. If you can conjure up that image in your mind immediately, then that means you've probably committed them to memory. But just sit down and stare at them and commit it to memory long and hard. And the way they work is we have two expressions that are evaluated concurrently. So expression one in the case of this program is that the upper limit is greater than 20, and the second expression that's evaluated concurrently is that the upper limit is, I said upper limit greater than 2, and the upper limit is less than 20. So those are the two expressions. So where you see expression 1, you can just plug in this. In the case of our program example, where you see expression 2, you can just plug this in from our program example. And if you enter in a number, let's say 12, I think that was the number that I provided initially. If 12 is the value that the user inputs through the form, that's the value that's passed through the parameter of the function. If that's the value that is evaluated here, then expression 1 would read 12 greater than 2. 12 greater than 2 would be a true expression. And expression 2 would read 12 less than 20. 12 less than 20 would also be a true expression. And in that case, both expressions would evaluate true. So expression 1 would evaluate true. Expression 2 would evaluate true. And if I had put in a parameter value of 1, which was another example that I showed you, then upper limit greater than 2 would evaluate false, but upper limit less than 20 would still evaluate true. So we'd be looking at a false true situation. And if I put in a parameter value of 21, then we'd be looking at a true false situation, where 21 greater than 2 would be true, 21 less than 20 would be false. Okay, and there's really no way that I can put in a false expression here, but what the truth tables tell me that is, if I use the OR operator, which is the most permissive operator, that's the easiest one to get an overall outcome of true from. If I evaluate this these two conditions concurrently with an OR operator, then a true gives me a true false gives me a true, a false true gives me a true. And for my purposes, I want both of those expressions to be true in order for the entire overall outcome to be true. So OR is not the way I want to go in this case. There are times when the OR operator is appropriate, but in this case, what I'm really looking for is when expression 1 evaluates true, expression 2 evaluates true, then I want to have a true outcome, allow the true path to be taken in the if statement. When expression 1 evaluates true, for instance, 21, if I put in a value of 21 greater than 2 would evaluate true, but 21 less than 20 would evaluate false. And if I put in a 21, I want the false path to be taken, okay, and the AND operator would do that. If I put in a value of 1 greater than 2 would be a false expression. 1 less than 20 would be a true expression. I'd be looking at false true here. Okay, so clearly the way I want to set this up is using the logical operator AND. And in JavaScript and all C-based programming languages, the logical operator AND is denoted with ampersand, ampersand. Okay, so let's look at the program code. And again, what you should see here in the program as we analyze it is that we're going to have a looping structure that's going to be nested within a two-way decision structure, and that two-way decision is going to be based upon compound logic where two expressions are going to have to be evaluated concurrently with a logical operator AND. So I'm going to flip over here to the program and take a look at it. Okay, so here's my program, and if I right click and choose View Page Source, what I see is the usual HTML code through what I have highlighted. I see my new and improved function genFib sequence. Okay, so if you recall, that was the name of the function I used before, but this time I've changed the instructions in the function, so it's going to behave a little bit differently. And here's how it's going to work. It's going to declare the variables the same way I did before for the same reasons. Then, this is new, this function, when it gets called up, is going to call another function. So when I click the button to generate the Fibonacci sequence, as a result of running that JavaScript function, that JavaScript function will call up another function. There's going to be a function call made here, and that's why you see the alert message that reads "made it." I just put that in so I could kind of follow the way the program was executing, just monitor how things were working. And so it is going to clear out both of the text boxes and then put the focus on the first text box, the text box where the user is expected to input a value. So when the user puts in a value into the text box, clicks the button to generate the Fibonacci sequence, they will be passing an argument, same as before. The argument is assigned to the function's parameter. The function then declares the variables, calls up another method to another function to clear out the form. And then we get into what was described in the Word document with the flowchart. And what we have is a two-way decision structure. Notice that this is an if-else statement. The true path is outlined, is highlighted here. and the false path is highlighted here. So what kind of things go on the true path? Well, first of all, when the if statement is evaluated, notice that two things are being examined. Two things are being considered concurrently. We check to see if the upper limit is greater than 2. We also check to see if the upper limit is less than 20. And I'm using an AND operator. So in this case, because AND is very restrictive, and the only way I can get a true outcome from an AND is when expression 1 and expression 2 evaluate true. That's my only way of getting a true outcome. Then in the if statement, so long as I have a value that is greater than 2, and also so long as that value is less than 20, it will take the if path, and on the if path it executes the program code that we saw previously to generate the Fibonacci sequence and eventually output that Fibonacci value to the form. Okay, so I am outputting that Fibonacci value to the form. I see a little mistake here, and we'll come back and take a look at this line right here. But for now, it's working. I can make this a little more efficient, though. So along my if path, I have my for loop. Along my true path here, this would correspond with the if path, I have the for loop. In the event that the expression evaluates false, in other words, if either this condition in and of itself or this condition in and of itself evaluate false, or if they both evaluate false, then this if path, this true path, is not going to be taken, and instead we take the else path, and the else path is going to fire off a message. Logically, the false path fires off a message. Okay. So everything is wrapped up in a two-way decision. Now, I mentioned a moment ago that I had something that was a little inefficient here. What it's going to do is every iteration it's going to update the text box on the form, and it really doesn't need to do that every iteration. It just needs to do that after it has completed all iterations. So what I'm going to do is take that line of code that assigns to the form, and I'm going to move it down here outside of the for loop. I'll keep it in the if path, the true path, but I'll move it outside of the for statement, and that way that assignment doesn't happen over and over again. It just makes for more efficient executing code. So let me do a Control C on this, and I'm going to do something here before I do anything else. I'm going to run this program again, and I'm going to run it with a value of 3, which puts me on the true path. I run it with a value of 5. That puts me on the true path. I run it with a value of 19. That puts me on the true path. And I'm getting the output that I would expect here. It's just that it's rewriting this too many times. Every time it goes through the loop, it rewrites it. Now I'm going to close this out. I'm going to go back to wherever I can edit this, and I'll just open with Notepad, and with Notepad I'm going to look at the script in the for statement right here. Control X, and I'm going to move this still within the if path of the decision structure, but I'm going to move it outside of the loop, and I'm going to save this, and I'm going to now run it again, sure I don't have that open already. I'm going to open it with Firefox. I'm going to run that program again with a value of 12. And you'll see that it is producing the intended result. Now, you're never going to notice it because the computer can process so quickly that it's not noticeable to a human, especially with such a small set of data. But if I were trying to generate a very, very large Fibonacci sequence, then that inefficient code, putting that assignment statement within the loop, might begin to degrade the performance of the computer. So it's possible to get correct output from a program without necessarily writing it as efficiently as possible, okay, as I demonstrated there. Okay, I think I have told you about everything I need to tell you on this program. Let me go back one last time just to point something out. So this program generates the Fibonacci sequence. Things that are different about it is I've got a function that calls up another function. You haven't seen that until now. And I have a flow of control structure that's more complex, where I have a loop within one branch of a two-way decision, and I have an alert on the other branch of the two-way decision. And hopefully that makes sense, and I'll be ready to move on to program demonstration number 3.